Hello students, we shall continue the session on playing with the numbers. In the previous session, we have learned to find out the highest common factor by prime factorization method and also by division method. We have solved the questions wherein the two numbers were given. Suppose if three numbers are given, how do we find the highest common factor? If suppose the question is find the highest common factor of 2261, 3059 and 3325. I had given you an hint in the previous session that whenever there is a large number, it's always better to follow long division method. So let me follow in this way. Step 1, I would like to divide the first two numbers. I would like to consider the first two numbers. In these two numbers, we have 2261 smaller and 3059 is larger. So I would like to divide this. So one time it goes as 2261. Now we need to subtract. We will be getting 798. Now this particular 798 will act as a divisor and the earlier previous divisor will be dividend. So now I need to divide. So 2 times will be the nearer number. So 1596 to be subtracted. Upon subtracting, I'll be getting 5, 6 and 665. Now with this 665, I need to divide the previous divisor. One time will be 665 and it leaves the remainder as 133. Now 133 we need to divide 665. It exactly goes with 5. So with this I got the highest common factor of two numbers 2261 and 3059 as 133, because 133 is a divisor when the remainder becomes 0. Now we need to find out the highest common factor of 133 and the next number. That I will take as a step 2. So step 2 is find. Now we find highest common factor of 133 and the other number 3325. So 133 is smaller number. We divide 3325. It goes with 2 times. So first 3 digits we have to consider. 2 times is 266. You subtract. Upon subtracting, we will be getting 66. You take this carry 5. So 665 is 5 times. We get it as 665 only. Therefore, highest common factor of 2261, 3059 and 3325 is 133. Hope you have understood this. We shall solve application of this type of highest common factor, I have brought in some questions for you. We shall solve one by one. First we will understand the question. Very important thing is to understand the question first. So the first question, application type is, it is given that $65,610 is divisible by 27. Which two numbers nearest to 65,610 are each divisible by 27? You have understood the question? It is given that 65610 is divisible by 27. Which two numbers nearer to this 65610 are also divisible by 27? First, let me check whether the given number is divisible by 27. I will actually divide. I will divide 65610 by 27. Let me see what quotient I get. 2 times is 54. Subtract. You will be getting 11. So take this 6 carry. So 116. Yes, if you take 4 times, we will be getting 108. This will be nearer number to 116. So subtract, we will get 8 here. So take 1 carry. 1 is taken carry. So 3 times exactly is 81. Here there is 1. So sorry, here there is 0. The next digit I have to consider here as 0. Therefore, the quotient obtained is 2430. So I will write this in mathematical way. 65610 upon division by 27, we get the quotient as 2430. The numbers nearest to 65,610 and divisible by 27 will be 2430 minus 1 multiply to 27. If you multiply this 2430 with 27, we will be getting 65610. Now I will take one number less than this quotient. Then if I multiply, I will be getting the number as 65583. This is the nearest number to 65610. The next number which is nearer will be 2430 plus 1. The next number I have to consider. I will be getting 65637. If you observe properly, what I have simply done is I have added 27 to the given number. 65610 plus 27 will be getting 65637. If you subtract 27 from here, I will be getting the previous number, which is 65583. So by subtracting 1 and by adding 1 to the quotient and multiplying with 27, we get the same result. Since the number is divisible by 27, So I can add 27 and subtract 27 without actually dividing. This division I have done so that you will realize that the numbers obtained will be the numbers obtained by subtracting and adding the given divisor. In other words, if I take a simple example, say 2 divides 10. Which are the numbers which are nearer to 10, which are divisible by 2? Will be 10 minus 2 and 10 plus 2. It will be 8 and this will be 12. These are the numbers. In the earlier case it was 65610. When it is divisible by 27, what I need to do is 65610 minus 27 and 65610 plus 27. If I do subtraction here, I'll be getting 65583 and 65637. Now you must be clear now. Alright, let us solve another question which is considered to be very important whenever there are some competitive examinations. These type of questions will be there. What's the question? The question is, find the largest number which divides 245 and 1029, leaving remainders 5 in each case. Just observe the solution. They have given that remainder in each case is 5. Therefore, the numbers exactly divisible are, we need to subtract this 5, then only the number will be exactly divisible. That's a common sense. So if you subtract 5, you'll be getting 240, and the other number 1029 minus 5, you'll be getting 1024. Therefore, the highest common factor of 240 and 1029 will be the required larger number. So what you need to do now, we need to find the highest common factor of 240, and I have made a mistake here. Observe, this is 1024, 240 and 1024. To these two numbers, I need to find the highest common factor. To find the highest common factor, what I prefer doing is division method, because these two numbers are comparatively larger. Let me take the smaller number now. The smaller number among them is 240 and the larger number is 1024. So let me divide. If you multiply with 4, I'll be getting 960. This 960 is smaller than 1024, nearest. So subtract, you'll be getting 64. Now we need to divide 240. It goes with 3 times as 192. Subtract it, we'll be getting 48. Once again you divide 64. So 48, 1 time is 48. Upon subtraction, you will be getting 16. 16 divides 48 exactly by 3 times, so remainder becomes 0. Therefore the largest number which divides 245 and 1029, leaving 5 as a remainder, will be 16. Do you want to verify this? So let's verify. It will not be asked, verification part will not be asked. However, I'll tell you how do we check whether our answer is right or wrong. Suppose if I divide this 245 by 16, do I get the remainder as 5? So 16 one time is 16. On subtraction, I'll be getting it as 8. 5 is taken carry, 85. So 16 5s are 80, and we get the remainder 5. So it is verified. At the same time, can we verify for 1029? So let me consider 1029 now. 1029, let me divide by 16. 16 6 are 96, it is nearer to 102, so 16 6 times is 96. On subtraction, I'll get 6 as a remainder, so 9 is taken carry, 69. 16 4 times is 64. Subtract, you'll get the remainder as 5. So 16 is a larger number which divides both 245 and 1029, leaving the remainder 5. Now you must have understood it. Since you have understood it, I will find the largest number dividing 3 different numbers, leaving 3 different remainders using the same procedure. Now the last question for today's session, very important question. Please make a note of it, write along with the question, it's important. So it's important question number 3. Find the largest number that will divide 398, 436 and 542, leaving reminders 7, 11 and 15 respectively. If you can observe, in the previous question they were leaving the remainder same, so we had subtracted 5 from each. Here they are leaving different reminders, so now if I subtract this 7 from this number, I'll be getting 391. 436 minus 11, I'll be getting 425, and 542 minus 15, I'll be getting 527. Therefore these numbers 391, 425, 527 will be exactly divisible by the given largest number. What will be that largest number? The largest number will be the highest common factor of these 3 numbers. So when 3 numbers were there, we have learned we will follow stepwise. In the step 1, we will first find the highest common factor of 391 and 425. So let us do that. Step 1. So 395, see 391 divide 425 one time, it is 391, and the remainder will be 34. Now 34 divides 391 11 times, you will be getting I'll do one thing here. The space is not enough. I will take this part to the next page. I'll refresh. I'll once again find the HCF of the numbers 391 and 425. Since the space was less, I am taking this separately and solving it. One time is 391 and the remainder obtained was 34. Now I need to divide 391 with 34 as a divisor. One time is 34. I'll be getting 51. This 51 is also divisible by one time. It becomes 34. And the remainder obtained is 17. Now 17 divides 34 two times, so I'll get the highest common factor as 17. This is the first step. What is the next step? Step 2. Step 2 is we will find the highest common factor of the HCF obtained in the earlier case and 527, the third number. So I will divide 527 with 17. Seventeen three times is 51. It leaves 1, carries 7. 17 ones are 17. So remainder is 0. Therefore, the highest common factor of all the three numbers 391, 425 and 527 will be 17. Therefore, the required larger number is 17. Hope you understood this. Keep practicing. Practice the same questions, then we will take up the new questions which are very important for any of the competitive examination and also the examination point of view. Thank you.